Thank you so much for joining us. My name is Sahil. We will be discussing mastering data engineering migrations to Snowflake. I'm a solutions architect with professional services with Snowflake, and we are very happy you're here. I'm joined with Tom. Do you want to introduce yourself, Tom?
Yeah, good afternoon, everyone. My name's Tom Ridinger. I'm a senior solutions architect. Sahil and I both are part of our professional services team. So we get to work one-on-one with customers and helping them migrate environments into Snowflake. We're going to tag team on the presentation here, so we'll switch back and forth to maybe keep it a little more interesting. So let's start with just the agenda items we're going to try to cover today. Certainly, it's a very big topic. We can't cover all those, so we're going to hit some of these at 10,000-foot view. Some of these we may dig down into a couple of areas that we have a demo and other things we'll show as we get through this. So we'll start with an introduction to data engineering in Snowflake for those that may not have a lot of background with that. We'll talk about Snowpark benefits and a little bit around a migration strategy if you're wanting to move into Snowflake and Snowpark, things you might want to consider. We'll provide a few reference architectures for your review just to get an idea of how is the architecture the same or different, specifically between Spark and Snowflake is where we'll spend most of our time. Certainly data engineering is beyond Spark, we understand that, but we're going to try to talk a lot about that today. We'll share a customer success story of some that we've worked with in the past and just show some of the outcomes that came out of that. Sahil will talk a little bit about our CI/CD pipelines and how do you manage publishing and pushing your pipelines in an automated fashion. I'll talk about data validation and how that's important to your project, and then we'll wrap up with a demo. So let's start with just looking at some of the traditional approaches why you might consider Snowflake over maybe a traditional Spark implementation. So if you're running Spark today, what we have found in many of the customers we work with, some of the challenges that I've listed here. So you'll see things like often customers may run separate clusters for different languages because there's ways to optimize those clusters for those environments. Capacity management and resource management is somewhat complicated in Spark compared to Snowflake. I'm probably a little biased in that, but I think most will probably agree. You have to know, Spark can do very good, but you have to know it very well to tune it very well. And that's really, we'll dig in that a little deeper why we think we do a better job there. In some environments, you may get vendor lock-in, like proprietary data formats or proprietary catalogs. We'll talk about how we think we have a better solution there. We'll talk about data can be siloed in your environment. Not that you can't get to it, but it can be a little harder for other companies or other businesses to get to it, how we think we have a better story there. And we'll talk about disjointed governance and security controls. So let's start with just separate processing clusters. Snowflake, we offer one single runtime environment. That runtime environment is really for all languages. So there's really no different infrastructure management for Python versus Java or Scala or whatever tool you're using for your data engineering. There's no different environments. It's there, it's available, easy to use. As far as for capacity management, resource sizing, if you've been around Snowflake very much, you obviously know that we do simple t-shirt sizing for our warehouse sizes. If you want more capacity, you want more performance, you simply go to a larger warehouse, a larger t-shirt size. And if you've heard some of the announcements that we had this week around adaptive warehouses, that's going to really even be easier in the future, where you don't even have to think about t-shirt sizing or other clustering or other type of how many concurrency I want to handle. That'll all be automatic in the future. Next, data formats. You have probably heard about Iceberg. If you have not, obviously it's an open format that we've strongly embraced in the industry. We think it offers the best solution that's a fully open data format. And we also think not just do the data formats need to be open, but also the data catalogs. So as you know, we're a big sponsor of the Polaris open source project for an open catalog as well. And we have other integrations with our environment as well with that. But we really want to be open from a data format and a data catalog standpoint. Data sharing, as you know, can be difficult in some environments. We're really the industry leader in data sharing, whether you're across cloud providers within your organization, Our whole marketplace is quite robust there. We've had that for many years. We think we have a very good story to tell there. And then governance and controls. Not that any environment's perfect, but certainly we offer a fully integrated environment for all your governance and controls. There's not like, you don't think of your Spark admins versus your data engineers and they're managing it. These guys manage infrastructure, these guys manage that. We have a fully managed environment where the governance is all integrated in one place. This slide here shows kind of a variety of the tools and technologies that Snowflake offers in the data engineering space. If you've been around Snowflake for a while, you're probably going to see a lot of new names up here. These are a list of a lot of the tools. If you're doing data engineering, you may use many of these concepts that are out there. Certainly you can just lift and shift your code if you like, and that may work in many cases, but you want to leverage our native tools and technologies where possible because they're probably going to perform better, be more cost effective, or simpler to use in terms of that. Next, I'll move to talking about Snowpark itself. Really, if you're talking about data engineering and Snowflake, you have to talk about Snowpark. This slide here describes some of our libraries and execution environments that we have. Our data frame API model really closely resembles the Spark data frame or Pandas data frame that you're used to working with every day. Obviously, our execution environments really let you pick a native warehouse to run in. As I mentioned earlier, you can run in a native warehouse, or you can run in Snowpark Container Services, which is kind of your own Kubernetes-based environment as well, depending on how you'd like to run your code and where you would like to run your code. If we look at the execution flow of the API, you can see you're running your language of choice at the top. You make a call to the API. Now, this could be running client-side, or it can be running server-side. Your choice in terms of where you want to run Snowpark. But when you actually get to interacting with the data itself, what happens is this API call generates SQL pushdown in the background, and it's going to push SQL to your backend database. As you probably know with Snowflake, we started very well in the industry in high-performance SQL, and our Snowpark engine leverages that. So if you're wondering why you're saying it's so fast or what's so good about Snowpark, we actually push that down to native SQL. So if you look in your query history or somewhere else, you'll actually see when you're doing a data frame operation, SQL running under the covers, running that operation. I'm going to transition to Sahil. He's going to talk about some migrations.
Thank you very much. All right, let's jump in. We over here would like to talk about like the optimal strategies if you have different volumes of data and what might be the best approach for you. And these are based on our customer experiences and the migrations we have done. Over to the left, we have tools like JDBC, AudioBC, Python, and third-party ETLs, and they're great, but they have their own limitations. As an example, with JDBC, it's limited to Java. It's just row-by-row operation, but if you're dealing with a lot of data, it tends to be a little bit slower. Other than that, for example, third-party ETL tools, we work with them. They're great, but again, those connectors that are created may or may not be as optimized. That is not to say they aren't helpful. In the center, we have Spark connector. We call it our Snowflake Spark connector. We write directly to Iceberg, and it's a solution that our team built to effectively connect with Snowflake, and we can just use the write operation to write a data frame to a native Snowflake table. Lastly, which is the most performant one we have seen, and a lot of clients moving there, is a Delta Direct, Databricks Uniform, and Copy Into. We'll be diving into them in the next slide, but the idea is we want direct connectivity. We are allowing you to be interoperable, and we don't want you guys to be tied to one environment, and gives you the flexibility to open up. So here are two scenarios for Snowflake Delta Direct and Databricks Uniform. They're mostly the same. They allow you for the native Iceberg compatibility without additional metadata conversion. There are scenarios when they are helpful, but before we jump in, I'd like to summarize a little bit about both of them. In Snowflake Delta Direct, Snowflake directly understands the Delta log files and converts them into Iceberg tables, and you consume them as is. And the Databricks Uniform is Databricks' own utility, wherein when they write the Delta file, they also write the metadata for the Iceberg tables, so you can create them as Iceberg table and then use them. Now talk about the scenarios when one would be helpful over the other. As an example, for the Snowflake, it really helps when you have a Snowflake-driven strategy and you want to manage our catalog, you want to get the performance gains and everything, and we simplify the integration strategy for you. Snowflake runs a lot on simplicity, and we want to make sure you guys don't have to go through all the pain. We abstract a lot for you, so it really helps. And another thing is, if you don't want the full CDC, change data capture, any deletion vectors, or the time travel. Now let's talk about when would you prefer the Databricks. We have seen a lot of clients or companies have a Databricks org, Databricks platform within their org for the machine learning and everything, and you want to maintain that, then it will be a right place to do that. And you want to maintain the Delta functionality. Lastly, you also have a uniform configure. That's one of the requirements. This is one of the example. We'll go left to right. We have several source engines here. As an example, Databricks, Spark, Fabric, and Python. Very simple. In the storage layer, in the Delta Lake or the Parquet, you have the Parquet files with the related metadata, and you just do 4 steps. You create the volume, and then you create the catalog integration, create the Iceberg table, and set the refresh schedule. It can be auto refresh or on a schedule, and it's ready to be consumed by your third parties, tools, or any applications. With Iceberg, you also get an advantage. You're not replicating your storage, so it allows you to not pay the cost again, but you can leverage Snowflake's compute to make things faster. Now let's talk about migrating the Spark code using the Snowpark migration accelerator. It's one of the accelerators that Snowflake has created, and it's free to download. It runs on your local computer. It doesn't need to be connected. It works on your file folders that you have, the Git repo, and it provides you an output letting you know what's the compatibility between the Spark and the PySpark and the Snowpark. We will also give you a demo, and the output is designed to mirror the functionality of the original. But I would like to highlight that it's an assistant. It won't do the conversion for you. So once the conversion is done, most of the heavy lifting is done. What you have to do is realign a few things, and it's as easy. This is one of the example reports that get generated, and it tells you the percentage compatibility. As an example, the usages of PySpark it has found, and it also provides, as an example, the reference inventory of what libraries are being involved and what are third-party libraries involved. We are very good at also explaining any error logs or EWIs, here error warning indicators, wherein we couldn't convert anything, but we provide you a reference. Okay, this is something you could do as a workaround. And when the reports get generated, there's a link to that error code. When you click on that, it takes to the SMA documentation, which allows you to understand even better. Tom?
Thank you. So we're going to take a little closer look at some of the challenges that I mentioned earlier. So I'm going to take just a little deeper dive and maybe show you a reference architecture for each of those. So let's talk about the different clusters that I mentioned earlier. This architecture diagram sort of plays to that to just show it's really one simple warehouse or one simple environment that runs all of your code. So there's no different environments. Managing environment is far easier than managing a Spark cluster in terms of bringing that together. And probably if you've worked with Spark very much, in many cases, depending on what you're doing, the startup time for a cluster can be measured in minutes quite often, right? If you've used Snowflake in the past, you're going to say, wow, right? We keep a hot pool of warehouses available for you. So typically when you ask for a warehouse, it's instantaneous or less than a second, typically, in terms of that. So I think you'll see in most times the compute resources that you need are there almost instantaneous when you ask for them, whatever sizing needs that you have there. Capacity management, as we kind of mentioned before, it is simpler. Here's a diagram showing our t-shirt sizes that we have, along with those hot pool of resources that are available for us to go pick when we need them on demand. So it's really just, much, much easier to do it. And we don't, by design, we don't provide a lot of tuning knobs, and that's by design, right? We try to make it as simple as possible. Yes, there are ways to tune, but not far as many as Spark and not near as complex. Next, talk about data movement. If you're in a situation of where you're kind of running both, and lots of customers are where they're running both Databricks and Snowflake, and you're doing your data engineering pipelines in Spark, and you're doing your data warehouse, for example, in Snowflake, one thing that's involved there is there can be quite a bit of data movement between the two environments, right? And with that data movement comes performance and cost implications with that, right? The more data you're moving, the longer it's going to take. And anytime you're moving data out of Snowflake, you're going to have a warehouse up and running to support that as well. So you're paying cost to run that across there and doing that. And this can be significant. I'll show some slides later on our customer study of how much they were actually spending on that because they had a dedicated warehouse. Governance and security, our Horizon catalog, again, it's a unified experience for governance and security. Lots of security controls across the board. And it's really been from day one, security has always been a top concern for Snowflake in terms of how they implement that. And we really just make that much easier. So here's the success story that I alluded to just a moment ago. I've had the opportunity to work with this customer. We spent almost a year with them in doing this. So it's a fairly large migration that we did. Chicago Trading Company, they're in the financial services and trading industry. They had a very large Databricks installation. And they already had their data warehouse in Snowflake. So as mentioned, they were doing lots of data movement. Their goal here was twofold, really to reduce cost and simplify the architecture. And you can see from the outcomes across the bottom what those outcomes were. Because they had dedicated warehouses to track that data movement, you can see they were spending $800K alone just in data movement. These were very large volumes. They were running, it says here, thousands of jobs a day, but I know for a fact I saw it peak at 400,000 jobs in one day. So this was a very large environment, lots and lots of jobs running at scale. We were able to take that right off the board without doing anything else, save $800K because there was no data moving outside that when the processes were running, it was running in the environment. It actually equated to a 54% annual cost savings for those, which really was millions of dollars per year in terms of savings. You'll also see that last outcome I mentioned there, fewer failures. You'll see their note where they mentioned first time ever in company history that they met every SLA deadline for every day after moving to that. They had lots of failures in Spark, and those guys were good at Spark, but it's just a lot of introvert. At that scale, you can imagine the types of problems that they had. And I got a few quotes there you can see from their head of data engineering that gave some quotes on that. And there's a link on the bottom here that shows if you want to go read the case study on your own. So next we're going to transition to CI/CD.
All right, thank you very much. At Snowflake, we really want our developers to have a thorough experience. As you can see, we want to support you through your code, through build, to your customer testing and release and deployment and all of these operations. There's several tools that team has created like CLI, Git integrations and everything. And you can do the deployments from the CLI as well as you can build your code within your CLI as well. We'll touch more on those in the next slide and we'll provide you a demo as well. But we also provide you declarative change management. You don't have to maintain the versions and those kind of things not being imperative. And we let you control a lot more things. And we think these tools will really help our developers. As I mentioned, Git integration and Snowflake CLI are two powerful tools that are transforming how developers are working right now with Snowflake. We work with our clients daily and we hear that their CI/CD pipelines and the developer experience has been better in the past years since we worked on these enhancements. The Git integration in Snowflake allows you to view, run, edit, and collaborate with the Snowflake assets directly from your Git repo. And by which it allows you that each developer works on the same copy and you can work with other Git conflicts and everything you can resolve so that there's a less burden in terms of managing the overhead. The primary benefit of enabling truly collaborative environment and faster deployment through seamless CI/CD. One of the clients we have been working with, it automates every time the code has been deployed. It automatically deploys, tests, and makes sure the report is generated and creates the code coverage report. We'll try to provide a demo for that one as well. So over here, this is a GIF image. It shows you how it runs. Our CLI is open source. There are simple commands to create, and if you do snow help, you'll get to know, and there's good documentation that allows you for the faster learning. Now let's talk about few important files that Snowflake CLI needs in order for it to work. One is config.toml, wherein you establish your connections. Let's say you have multiple connections in different regions or different environments. You can define multiple regions or multiple environments and then have a default connection. Let's say if you have a default connection and you still want to test other one, there's a connection flag that you can issue to change and run on a different connection or deploy on a different connection. One thing to note, if you have a connection.toml in your .snowflake folder, the CLI will prioritize that over config.toml. Now let's talk about snowflake.yaml. It's a project definition file. Any assets that we deploy and build have to be defined here. Any notebooks, any procedures, any functions, we define here. And we kind of define, we can also define what it needs to return, what kind of data types it expects, and what kind of Python version it needs to run on, which stage it needs to get deployed. You can define all of them programmatically within a YAML file. This is how it looks. As an example, snowflake.yaml, requirement.txt. Requirement.txt, we haven't touched a bit, but it's all of the dependencies you have within your application, Python application, or any other application that you package up. And then using the CLI, you issue these commands. They are not ordered. These are just examples. So for example, the first two are related to Snowpark. The last one is related to Notebook. So when you issue a Snowpark build, it creates a zip file, packages up your application. And when you do the deployment, it deploys to the stage that was defined in your snowflake.yaml. And then those get referenced. We'll show you those things as part of the demo, and then those get deployed and ready to be consumed. All right.
Okay, I would be remiss to talk about migration if I did not talk about data validation. Unfortunately, it's a topic for data engineering. If you're going to be doing a migration project, that we're going to have to talk about. And there's a couple of things I'd like to cover here. We have found that data validation can consume lots of your time in a migration project. So our recommendation is to do automation where possible, and where can we minimize and automate that as much as possible. We'll be sharing a link at the end of this that what I'm going to be talking about here is a custom framework that we developed. You're free to go download it and look at it, use it, not use it, whatever you like. But we'll share what knowledge we've learned from doing this over the last few years. When you're doing data validation, there's at least three patterns you could follow for that. You could do row counts. It's a pretty good start, but it's probably not good enough for production quality validation. You want to do more than just saying, yeah, the row count matches. The approach that we found that kind of works best is what we call aggregate measures. Aggregate measures is basically a way that you give us the two tables that you're interested in comparing, one from your Spark code, one from your Snowpark code, for example, and we actually profile those two tables and see if the profiles match. Profiling would be things like min value, max value, number of rows, distinct counts, number of nulls. We also do a hash value where we hash and see give us a unique fingerprint for all the values in the table. So we have a very good level of confidence by just doing that profiling. Do the things match or do they not match? Also, it doesn't require a primary key to do this comparison, which often in large-scale migrations, you may or may not have primary keys defined on all your tables. And then the third option here, which is probably the most detailed, would be what we would call a row-by-row comparison. It does require a primary key. It typically gets involved when we're doing root cause analysis for why something did not match. It's the next step we take in that. This framework has some functions as well that will make it available for you to see. This slide here just really describes the profiling and comparisons of how the process works. We profile the data from Spark. We profile it from Snowpark. We collect that into a central table. We have some views and other things that does comparisons with it, and we have a Streamlit app on top that can basically show you what passes and fails. This is a sample screenshot of the Streamlit app. Didn't mention as well, the app can also do DDL comparisons as well. So if there's different data types or other things between the two, it's going to let you know. That's a possible problem. And there's some of the lists on the data validations that we cover there as well. Now, if you do have a failure, which does happen, how you go about doing that root cause analysis, we have another tool that can help with it. It's called Checkpoints Library. Checkpoints Library is really something that you can embed in your Spark code on your Spark side, and you can embed in your Snowpark code. This Checkpoints Library, basically, as the name implies, you can put it at different checkpoints in your code, just like debugging. It actually works within our Visual Studio plugin, works great there. Or you can also just have the checkpoint profile it to a Snowflake table. And this profiling is very similar to what I was describing around our other method that we have. They're going to profile min values, max values, and some other attributes about that. And then you can see where things went wrong at what step in the code. So when you're trying to debug and understand why does this not match, well, maybe it was some non-deterministic issue that you had in Spark that you didn't realize, and there's a different behavior in Snowflake. That's a common pattern we see, or whatever the problem is. It will actually see where it goes wrong, and then you can dig deeper to see where the problem was. Next, we're finally going to move to the demos. I guess you're going to spend 10, 12 minutes on those.
Sounds good. Thank you. All right. So we'll take an example. We'll convert a notebook. This is just an example PySpark notebook in Databricks that we have, and we'll try to convert it into Snowflake. I have it downloaded, and I have a full set of that available in a folder. But before I go there, this is the look at the Snowflake migration accelerator. And this is the tool that you can download from our website. As I mentioned, it's free of cost for any conversions you do. Whenever you start a conversion, you start with a project name, the input folder. This is the input folder I chose. I come here, choose a folder. If you see over here, we have Scala files, we have SQL files, Python files, IPNB files. And then there's the option to analyze a subfolder as well in case you just want to analyze a folder within your project folder. And then you need to provide an output folder. The output folder essentially will have any reports we generate or any conversions we do on your behalf. We ask you to provide an email address and your company name so that we have the records. And now, as an example, we don't have to do anything. I just click here and then do the assessment. Start assessment here. It will take about 20 seconds. It really depends on how large your workload is and what your local computer memory is, but it shouldn't take as long. As you see, it took about 10 seconds and it completed the analysis. If you click on the view results, it'll create a report like this, but it will also create a report folder into the output directory that we did mention a while ago. Over here, as an example, you will see it says that it is 96.9% compatible. As a general rule of thumb, like what we have seen doing these migrations, most of the code is approximately 80% or more, but if there is less, we can still assist as part of professional services. It did say that there are about third-party libraries and there is SQL compatibility of 87.88%. Let's scroll down a little bit and try to understand what's going on here. So it says the number of issues are 14 and those are warnings, and number of unique issues are essentially 6. So they might be occurring more, but unique issues are 6. And over here, it will tell you like what kind of issue that is and how many times it's occurring, if it's a conversion error or a warning. As I was talking about a little while ago, that it'll tell you like if it doesn't recognize anything, you just come here, click on that. It tells you this is our website and tells you what you need to do. Okay, we'll go back. And this is the link to documentation. That's where you go. Now let's continue to conversion. The step it wrapped up is assessment, meaning it understood what your code is and what it contains, the libraries and everything, and created its AST diagram. Now we are moving to conversion, wherein it actually convert those libraries into Snowpark compatible libraries. Again, it will ask you where you want the output to be, and you will need an access code. In the previous step, we did provide an email. That's where you'll get the access code. I have a valid access code that I'm going to use to start conversion. Now it is going to start converting the files. And then you can see the results here. Okay? And if you click on the output, it opens up and it shows you the output folder. I already have this open on my VS Code, so let's go there. So this was the input folder SMA sample, and this is the SMA sample output. This is the one we ran 6:44 at 11:44 because the time zone, assessment and the conversion. Let's open this and let's take an example. Output, and let's open one file from here. So if you compare, on the left is your PySpark code, on the right is your Snowflake code. It was a little bit formatted, it's not formatted here. But if you see, the libraries have been converted, and over here it's still Spark, so we'll have to do a little bit of tweaking here. As I mentioned, it's a helper, it's not really doing all the conversions for you. But it lets you do the transformations and everything. And for example, over here you will see it also formats your code to bring it up to the level of code standardization, as an example. I already have a working version in the interest of time. So I have this Snowpark app that you can initiate. And in order to initiate a Snowpark application, there's a documentation, but it's simple. One command you issue here, Snowpark init, and then you mention your project name. That's where it will essentially go ahead and put your project. This is one of the projects I have created. And let me close this. So I have three things I want to show you. One is Snowpark, one is Notebooks, and one is the CI/CD. So let's go into Snowpark. One thing I would like to mention is, as we saw, there was an IPINB file or a notebook. You can convert them to a stored procedure, or you can maintain them as a notebook itself. So we give you those options, how you want to convert it. So let's take an example of the same file being converted to, as an example, a stored procedure. What I really did is I didn't add anything specific apart from the imports and the test. The reason I want to show you this is a very powerful tool. We have VS Code. In the VS Code, you have extension. You can connect, as I was talking about, and it knows the context and it knows where I'm connected to. At the bottom, you will see. So in case you want to test anything, you can come back and then test it. So let's go back here, and you can put the breakpoints. I'm going to put a breakpoint here, and that's just one example. So go through, do the debug and those kind of things. Okay, I'm going to stop it right here, but you get the idea. Now, let's see where I am. I need to be in the Snowflake folder. All right. Okay, so I'm in the Snowflake, and whenever you issue the commands, you need to have a context of snowflake.yaml. That's where it understands what it needs to do. So as I was talking about, now I'm gonna build this application. I'm gonna do Snowpark build and then press enter. I'll get a notification on my phone for a Duo notification. I'm gonna approve that. It will create an app.zip and put it in your repo. So as an example, this is that one. And if you don't want this to be pushed, you can change those configuration in your git ignore. And then you do Snowpark deploy. Since my procedure already exists, I'm going to do a replace here, okay, with a replace flag. I got a notification one more time. I'm going to approve that. So it tells me where it is uploading here, and we'll go to the snowflake.yaml file in a minute. And the procedures you see, hello procedure, test procedure, I just wanted to show you those because those are part of the template that we provide you. So when you experiment, you'll see the similar thing. And that's how it tells you where it's publishing and everything. And this is what it is and what it did. As an example, it updated the package here for the procedure. And then you can go on the Snowflake and have a look. Okay. Now let's go to the notebooks. So here are the notebooks as an example again, the same notebook but converted here. Few things I added is, and few things I wanted to show you is, we really encourage you to add the query tags. Query tags really allow you to figure out how many queries were issued within that session. And let's say if you want to debug anything, identify anything, you can narrow down by that query ID and the session ID, and it lets you understand that. As an example, if you see this is previously I ran, it gives you and the session ID, and you can go to the query history and narrow that down. Okay, and it's the same query and it runs through this. So again, I go back.
As you're mentioning, I mentioned query tags as well. If you're looking at trying to track your costs per pipelines, query tags are essential to having a way to do that. Because of our query attribution history, we can tell you a cost and an approximate cost per query. Then with the query tags, you can aggregate at that level. So if you're doing any deployment at all, you need to establish a query tag strategy that you're going to use across all your pipelines. It's going to make your life much easier in the future when you're trying to do cost attribution.
All right. So this is the notebook. I already had the code for this. So basically, I'm deploying a notebook and I'm letting it know which database I want to do, which schema I want to push it into, and if I want to replace it. The reason I wanted to show you this example is, as I was talking about, you get the option to overwrite what database, what schema you're trying to push it to. So as an example, if I do this, okay, so it will be Snow Notebook create, and then it will run it. Okay. Okay, let's open this real quick. And we'll give you the link for all of this documentation later on.
We can move that slide if you like.
What was that?
Yeah, we got like two or 3 minutes. We don't wrap up. So.
Okay. In interest of time, I'm going to show you a few more things. So as an example, this snowflake.yaml I was talking about, this is the procedure we updated, and this is the definition. And this is the version 2 that we are using. And this in version 2, you can define the mixins, and those mixins can be referred by each entity. And as an example, I'm mentioning here the Snowpark, and that's the context it needs to have. There are context variables that you can set for the environment. So in case you have a dev, prod, and everything, you can just have the environment variable and the context. It takes that, and based on that environment, it will deploy. This is an example for snowflake.yaml in the notebooks. Notebook will have a different entity, and this is how it's defined. You define the artifacts and the query warehouse and the notebook file name. One last thing I want to show is the CI/CD. So this is the CI/CD example. You can really define, this is related to GitHub. We support for others as well, example GitLab and those kind of things. You can define what kind of strategy you have on what actions you want it to prefer, and similarly you can define the secrets, and you define your jobs, what kind of jobs you have, like branch schema setup, you want to set up anything, and then when you run any test you want to do, and then deploy to prod as an example. So checking out the CLI, and then deploying. And then the way it does is build, deploy for the procedures, and goes back to the notebook folder and deploys the notebooks. And that's pretty much it. Thank you, everyone. And I have one more thing to show. One second, I'm sorry, I just realized. All right, so this is the document that is up and ready. There will be a QR code coming up, and you feel free to go through this. It's based on what we just discussed today, and it has Tom's information there to contact. We're happy to help in case you guys need any support later on.